Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss some numericals based on calculation involving unit cell dimension. Last class I told you that few examples I will give you, that is calculation involving unit cell dimension. Means in this type of numericals you will get the value of mass of the atom, density, molecular mass, all the things you will calculate. Okay, total number of atoms means Z value, small m value, capital M value, density value. Okay, all things you have to calculate. Then first example, numericals. Actually, this type of numericals may be asked in examination. Question I am reading, then I will solve the numericals. Question I am reading now. An element has a body-centered cubic structure with a cell age of 288 picometer. The density of the element is 7.2 gram per cubic centimeter. How many atoms are present in 208 gram of the element? This is the question. Again I am reading second time question. An element has a body-centered cubic structure, BCC structure, with a cell age of 288 picometer. The density of the element is 7.2 gram per cubic centimeter. How many atoms are present in 208 gram of the element? This is the numericals. Okay. Now I am telling you solution, answer of this question. Here what value actually a structure is BCC structure, body centered cubic structure. First things. Second things is its age is 288 picometer, means side is 288 picometer. And third things is given density of the element is 7.2 gram per cc. These three things are given. What is asking? How many atoms are present in 208 gram of element? 208 gram of the element. How many atoms? Okay, that you have to find out. Means Z, small z, that you have to find out. Then here, first of all, you should find out volume of the unit cell. Volume of the unit cell. Then it is very easy to find out the volume of the unit cell. Actually, here you know that in this type of numericals, always 2-3 things you have to determine, because in the formula you have seen that volume is required. Volume is required means like AQ. Volume is required, and this formula, density formula is related to Z, capital M means molecular mass, and age and Avogadro number. Out of 5, 4 you should know. Okay. Then volume first you calculate. After that, easily you can calculate the number of unit cells. In this volume, how many unit cells are there, you will calculate. And after that, you will calculate molecular mass, third step. And in the last you will get these things, density. You will calculate density. Okay. Then first you calculate volume. Okay. Volume first you calculate, then you will calculate number of unit cells in this volume. Then here volume how you will calculate? Then simple formula is there, AQ. Then volume of the unit cell. Then AQ means A is the side means age, Iitjee. Okay, Iitjee, age means a side. Then that is given 288 picometer. Then 288 power 3. That is that you will get volume. It is in picometer. 1 picometer means 10 to the power minus 12 meter. 1 picometer means 10 to the power minus 12 meter. Don't forget. Then 288 picometer, first you convert in meter. Then 1 picometer is equal to 10 to the power minus 12 meter. Then 288 means 288 into 10 to the power minus 12 meter. Okay. Then this is the age means length, A value. Then volume just power 3, 288 into 10 to the power minus 288 into 10 minus 12 and power 3. Then after this meter, you should also, this meter you can also convert into the centimeter. Then it is a minus 12 meter, correct? Then that if you convert into the centimeter, then it will be minus 10 centimeter, 10 to the power minus 10 centimeter. Okay, 10 to the power minus 12 meter. If you want to convert a meter, you want to convert into centimeter, then now power will be less. Because that is a negative. Negative power less means it is increasing. Okay, value will increase. Means now 10 to the power minus meter, now it will convert into the 10 to the power minus 10 centimeter. Then 288 into 10 to the power minus 10 centimeter power 3. Then you will get 2.39 into 10 to the power minus 23 cubic centimeter. This is the volume of the unit cell. After solving 288 into 10 to the power minus 10 whole power 3, then it will convert into 2.39 into 10 to the power minus 23 centimeter, cubic centimeter. Then now volume you are knowing. 2.39 into 10 to the power minus 23 cubic centimeter means cc. Then now now you are knowing volume of the unit cell you are knowing. Then after that you want to know, after this you want to know volume of 208 gram of the element. what will be the volume? That is in gram they have given 208 gram of the element. Then 208 gram element means what is the volume? It is in gram. 208 gram of the element. Then what will be its volume? How it is related to the these things? How volume? How it is related? How from the gram you will get volume? Then in this type of numericals, always remember that density, it is a density. Density is required here. Correct? Then gram and density means mass and density. If you are knowing, then formula you know. Density is equal to mass by volume. Then now mass is given, volume is given. Then quickly you can calculate the density. Okay. Then here density you have to not calculate because already density is given. Density of the element is given 7.2 gram per cc, already given. Means for 1 cc 7.2 gram, it is given. Then here you want to know the volume, and here this mass is given. Mass is given 208 and density is given 7.2 gram per cc. Then easily you can calculate the volume. Density is equal to mass by volume. Then volume is equal to mass by density. Then mass is given, density is given, hence volume of 208 gram. Easily you can calculate by putting this value. Then 208 gram divided by 7.2 gram per cc. That you put, and after solving you will get 28.88 cc, cubic centimeter. Centimeter cube you can tell. And now you got the volume. Now you got the volume of 208 gram of element. Volume you got 28.88 gram, 2.88 cubic centimeter. Volume you got, centimeter cube you got 28.88. And now volume you are knowing. Then if volume you are knowing, then what you have to calculate? How many atoms are present? How many atoms are present in 208 gram of the element? Then volume, now you came to know what is the volume of 208 gram. Then in this volume, how many atoms are there? Number of atoms we have to find out. How many atoms? Then here atom means number of unit cell. From this volume you can calculate number of unit cell, that just like in a crystal, many unit cell will be there. Many unit cell will be there in a crystal. Then that unit cell, how many unit cells are there? That you are talking about here, how many atoms. Correct? Then now number of unit cell in the volume, how will calculate? Then here volume is 28.88 and what you have calculated? Total volume you have calculated. Total volume is 2.39 into 10 to the power minus 23 cubic centimeter. Already total volume you have calculated. Correct? Then this you have calculated 2.39 into 10 to the power 23. That is actually volume of a cube. One cube means one atom. One unit cube. One unit cell. Unit cell, this is the volume of unit cell 2.39 into 10 to the power minus 23 cc. This is the volume of one atom, you can tell. One atom or one unit cell. Hence, total volume, if you will divide this, if you will divide 28.88 by this volume, 2.39 into 10 to the power minus 23 cc, then you will get the number. How many numbers are present? How many numbers are present in 208? Because one atom volume you are knowing, a total volume you are knowing. Correct? 28.88 is the total volume. Total volume of 208 gram element. And one atom volume is, you have calculated 2.39 into 10 to the power minus 23 cubic centimeter. Just to divide it by this number, then you will get it number of atoms present in 208 gram. Then after that, what you will get after dividing it, number of unit cell you will get, that is a 12 point, after solving result will come 12.08 into 10 to the power 23 unit cells. This you will get 12.08 into 10 to the power 23 unit cell. Since each BCC units, now extra things we have to apply. Since each BCC cubic cell consists of 2 atoms, correct? This is the only you have to apply. Okay, only you have to multiply by 2. If there was only one atom, then answer was 12.08. What you have calculated, that only. But you are talking about the BCC cubic cell. BCC cubic cell. Then in this BCC cubic cells contains 2 atoms. Therefore, the total number of atoms in 208 gram, that what you got, you multiply by 2, means 2 into 12.08 into 10 to the power 23. Then what you will get? 12.08 into 2, then 24.16 into 10 to the power 23. 12.08 is just multiplied by 2 it will come 24.16 into 10 to the power 23 atoms. This is the final answer. Then see, here numericals are not very difficult, but just calculation is there. When you are solving the numericals, first you think what you want and how will you get. That is very, very important. What do you want? First thing you think. Then how will you get? Theoretically you think. Formula wise, which formula you will apply so that you will get. These things you think. As for example, here you have thought that you require, if in 208 total volume, if you are knowing, and one atom volume we will come to know, means this here you can tell unit cell. If one unit cell volume we will know, then if you will divide, then you will get number of unit cell. And what type of unit cell is there? Then BCC. Then BCC contains 2. That's why I have multiplied 2. Then here, to get the you can say number of unit cell, you require 2 volume. First volume of the 208 gram element, and second things, volume of unit cell. Then now this volume of 208 gram, how will you come to know? How will you get this volume? Then that you have to think. Then you know, okay, that you will apply. Here mass is given and density is given. Then you will get the volume of 208 gram. Just back calculation, back way you think. What you want to start from there. And how will you get what you require? How will you get that also you think by reading the question. In the question they will give. Then you start from the, you can say last, from the result side, you can think. And back calculation you try first to think. As for example, volume you wanted 208 gram, volume of 208 gram, that you have calculated. That how will you calculate? Then for that, you know that mass is given and density is given. That's why I got the volume. And now in the end you have seen 1 unit, volume of 1 unit cell you wanted in the end. Then how will you get? Then for that also in question is given age. Age is given, means one side is given. Then like that way you think if you want to solve the numericals. This type of numericals are fit for Iitjee Advanced. Okay. Now second question I am reading. Okay, always you think what do you want and how will you get, which formula you need. Generally maximum 3 formula, minimum 2 formula they will ask, and for mains generally 1 formula they will ask. Use of 1 or maximum 2. But here in advance, actually in mains, Iitjee mains and medical, maximum 2 formula is required. But in advanced level, maximum 3 formula is required. Okay. Then you think what do you want, how will you get, which formula is required. If you will recall all these things, then you can solve the problem. And generally you try to convert in meter, length and other things. This if it is in meter or picometer like that, then centimeter finally you convert. For that meter, and then for meter centimeter. 2-digit difference will be there. If a minus 12 meter is there, then in centimeter how much? Minus 10. Okay, minus 10, because it is a minus. If it will be plus, then it will become 14. 12 become 14. If it is plus, but it is a minus. That's why it will be 2 less. Okay. Now second question I am reading. Try to understand the question before solving the numericals. X-ray diffraction studies show that copper crystallizes in an FCC unit, face cubic centered FCC unit cell with cell age of 3.608 into 10 to the power minus 8 centimeter. Age is given. In a separate experiment, copper is determined to have a density of 8.92 gram per cc. Density is also given. Calculate the atomic mass of copper. This time you have to consider atomic mass of the copper. Okay. Then in question they have given these things. Copper crystal, first they have given what type of crystal is there, then FCC crystal is there. First things. Second things, age is given 3.608 into 10 to the power minus 8 centimeter. Two things. And third things, what they have given, its a density is given 8.92 gram per cc. Okay, these three important points I told you is given, and you have to calculate atomic mass of copper. Atomic mass. Okay, and now first you think from what you want and go for back calculation, back way. Then first you want atomic mass. Then how will you get atomic mass? That you think. Okay. Then here first this atomic mass of copper, how will you calculate? That you think. How will you get? Then here you know you have to calculate. I am telling you, if a mole is there, molecule is there. If a molecule is there, then molecular mass you calculate, M. If it is the atom, then that formula only can be used, but it will be known as atomic mass. Correct? For the molecule, molecular mass, capital M. And if it is atom, we are talking about the atom, then same formula M, here it will represent atomic mass. Correct? And now here you know, last class I have discussed the formula, that relation I have derived, that density is equal to Z into M, Zm divided by AQ into N, means Avogadro number. Okay? Last class I derived density is equal to Z into M. Always remember, density is equal to Z into M divided by AQ into Avogadro number. Correct? Then this formula you are going to use. Density is equal to Z into M. Z is the total number of atoms. M is the molecular mass. Here you can consider as atomic mass. Divided by AQ into Avogadro number, N. Then this formula I will use. Then from this relation, you get the value of M. Okay, just you this formula, from this formula you can get M. Relation you can get M is equal to by cross multiplication you will get M is equal to D into N into AQ divided by Z. That you will get from the relation by cross multiplication. That M is equal to density, means density. Sometimes for density rho is written, rho, just like a P, a small p. But here D directly you can write. Density into N means Avogadro number into AQ divided by Z. Then here you can see this actually M you want to calculate. Here M represents atomic mass. Then see all things you are knowing here. Here density is given 8.92. Avogadro number you know, always you remember, always 6.022 into 10 to the power 23. Okay, particles, but here atom you can write because copper atom you want to calculate it in the atom form. Then 6.022 into 10 to the power 23 atoms per mole. Avogadro number means 1 mole. Okay, then N value you are knowing, and AQ, then AQ, A value is given, age, Iitjee age, side is given. What is the value? then 3.608 into 10 to the power minus 8 centimeter. It is given. Then it's power 3, that is the AQ. Then now above, upside you are knowing. Upside all three things you are knowing. D value you have kept. You have put the D value, you have put the N value, you have put the AQ value. AQ value you have put because A value you are knowing. Divided by, now we will think Z. What is the value of Z? Then here FCC. What type of cube is there? Then here one thing you have to understand. In case of a FCC lattice, number of atoms per unit cell is 4. Z is equal to 4. This you remember. This is the theoretical concept that in case of FCC lattice, number of atoms per unit cell is 4, means Z is equal to 4 atoms. Then here in formula you put down Z is equal to 4 and solve it. After solving you will get 63.1 gram. You will get 63.1 gram per mole. Then this is actually atomic mass of copper, 63.1 gram you will get. Atomic mass of copper is here 63.1 unit, you can say U, or 63.1 gram per mole. See how easily you have calculated. Don't afraid by seeing the question. Question may be long, but you think in a proper way, you will get the answer. FCC, you should remember that in BCC how many atoms are there, in FCC how many atoms are there, in cube how many atoms are there, correct? In simple cubic one, only one atoms will be there. Already I have calculated before the numericals. In BCC 2 and in FCC 4. This is required. Now next question I am going to discuss. Okay, again you read the question in a proper way before answering. Okay, don't be nervous. Now question I am reading. Silver forms a CCP lattice, and X-ray studies of the crystal show that the edge length of the unit cell is 408.6 picometer. 408.6 picometer. Calculate the density of silver. Now you have to calculate the D, density of the silver, and atomic mass is given. Atomic mass is 107.9 U. Okay, 107.9 unit U. Then say how easy this question is there. Direct you have to, you can say, put value in the formula. It is fully fit for main examination. Okay, because it is directly based on only one formula you have to use. Then here you want to calculate the density. Then density formula you have to keep in mind. Always this formula you remember. All numericals will be easy, and after that concept you have to apply. What data they have given in question you have to think over. Okay. Then now density you want to calculate, in this case D. Then D is equal to Z into M divided by AQ into Avogadro number, means Na. Avogadro number, it is represented by capital A and down A you can write. A, capital A, down N. N only you can write Avogadro number. Then 4 things required: Z, M, A and N. Then Z you know, because this is the CCP lattice. Okay, since lattice is CCP, cubic closed packing, the number of silver atoms per unit cell is 4. In this case also 4. CCP and FCC, you know, both are almost same, CCP and FCC. Then here Z is equal to 4. Okay, and I told you M, capital M, molar mass. In this case molar mass is equal to atomic mass. Atomic mass is also called molar mass. Okay, then here its value is already given, 107.9, that is the gram per mole. Then gram per mole is there, you can convert it into kg also. Gram you can convert into the kg. Then how? Just divide by 1000, because 1000 gram is equal to 1 kg. Okay, a standard unit in SI, because result will come in SI. That's why gram you are converted into kg. If you want to bring the answer in a SI unit, international system. And in CGS system, not required to change, only centimeter, a gram. CGS, centimeter, gram, second. That is in CGS. But in SI, international system, kg you have to use, kg and meter and second. Okay. Then here gram you converted into kg by dividing 1000. Then you will get 107.9 into 10 to the power minus 3 kg per mole. Okay, and after that age length is given 408.6 picometer. Then this you convert into the meter. Then 408.6 into 10 to the power minus 12 meter. Now length is in meter and mass is in kg, and you can directly get the density in SI unit. Then here you will put the whole value, means Z is equal to 4, M is equal to 107.9 into 10 to the power minus 3 kg per mole, and divided by AQ. AQ means 408.6 into 10 to the power minus 12, and Avogadro number 6.022 into 10 to the power 23 per mole. If you will solve this, if you will solve all the things, then you will get 10.5, you will get 10.5 into 10 to the power 3 kg per cubic meter, you will get, meter minus 3. Okay, this is the density, 10.5 into 10 to the power 3 kg per cubic meter. That is in SI you got it. If you want to convert into CGS system, then both you have to change. Kg you have to bring into the gram, and meter you bring into the centimeter. Then in that way, to convert kg you have to multiply by 1000, and to convert meter into second, again 100 you have to multiply, and finally it will result will come in CGS. In CGS system in gram per cubic centimeter, it will come 10.5 gram per cc. Anyhow, you can keep in any one unit, either in SI, because you have changed and brought in SI also you can keep. If suppose answer is given in option, all answer is in CGS system, centimeter, that is a gram and centimeter, CGS. C means centimeter, G means gram, S means second. Then according to the option, what option they are given, you apply either CGS or SI system. Then this I have discussed, you can say numericals based on you can say dimension, based on unit cell dimension. Like that way you can solve many other numericals also. There is no many numericals you will get. Okay, many numericals you will get, but now only these things you have to apply. This formula is very, very important. Now I am going to discuss this imperfections in solids. Imperfection questions are, many questions are asked. Okay, based on imperfection means you know that these crystals are not fully perfect. Okay, some defects are there in crystal. Okay, that I am going to discuss. Although crystalline solids have short range as well as the long range order in the arrangement of their constituent particles, yet crystal of you can say despite they have short as well as long range order in the arrangement, despite that crystals are not perfect. Usually a solid consists of an aggregate of a large number of small crystals. From the small crystals you can say solid is formed. Many small crystals will be there in a solid. These small crystal, now you think for a small crystal, not big. Okay, solid contains many small crystals. Then you think for one crystal only. Then these small crystals have defects in them. Okay, and this happens when crystallization process occur at fast or moderate rate. Why this defect happens? Then this happens when a crystallization process occurs at fast or moderate rate. Question is asked, okay, fast or moderate. Then single crystals are formed when the process single crystals are formed when the process of crystallizations occurs extremely slow rate. This is again question is asked. Single crystals are formed when the process of crystallization occurs in a extremely slow rate. Even these crystals are not free of defects. Even it is formed slowly, it is not perfect. The defects are basically irregularities. What is actually defects? Then defects are basically irregularities in the arrangement of constituent particles. They are not arranged in a proper way. That is the basically irregularities you can tell. Broadly speaking, the defects are of two types. Two types of defects are there. Namely, you can say point defect and line defect. POINT, point defects, and line, LINE, line defects. Okay, point defects are the irregularities derived from this how will you get point defect? Then point defects are irregularities and derived from ideal and deviates, you can tell. Deviation, it arises from deviation from ideal arrangement around a point or an atom in a crystal. Okay. Here there will be deviations from ideal arrangement. It should be in a proper way, but it will not arranged in a proper way. Deviation from their ideal arrangement around a atom or an or point in a crystal or in a crystalline substance. Whereas what is the line defects? Point defect I told you, that is it is can say deviation due to the deviation from their ideal arrangement around a point or an atom. What is the line defects? The line defects are the irregularities and is due to deviations from ideal arrangement in entire rows of lattice points, not due to, you can say, deviation around one atom. One atom is there and around that deviation is there, or point, only around that point, around that atom, if deviation is there, then you can tell that that is the point defect. But if it is can say in entire, if line defects are the irregularities, that is due to deviation from ideal arrangement in entire rows of lattice points. Entire rows of lattice point. And these irregularities are called crystal defects. Both line and point defects are called, these irregularities are called crystal defect. Okay, and now we will discuss, we will go for point defects more. It is actually big, that I will discuss in the next class. Okay, thank you.